All right, we're going to work on solving linear systems algebraically using substitution. So as we talked about on the first page, the 4 steps to solving an equation with substitution is, first I have to solve one equation for one variable, either the x or the y, and then I substitute this value into the other equation. So both of these are solved for y already, so the value of this y is 3x plus 2, so I'm going to substitute that value in here for that y. So the substitution would look like this. 3x plus 2 equals negative x minus 6. And I might have done it the opposite way. It doesn't matter. No matter what I do, I'll have one equation on one side and the other on the other. So these equations I would have to solve for the variable. Let's do this one because it'll be easier. I add 6 to each x to each side, and I'm going to subtract 2 from each side. Negative 6 minus 6 is a negative 8. Divide it by 4, and I get x is a negative 2. So this is solving the equation for the variable. These were solved for y's. Whenever I solve for y, that means I'm trying to find an x. I found my x was negative 2. This is half of my solution. Now, when the value of the variable is found, so I found that x is negative 2, we're going to substitute that into one of the original equations. So go back up to these 2 original equations, and I'm going to substitute this negative 2 into 3x plus 2. So y equals 3 times, instead of an x, I'm going to put negative 2 plus 2. So y equals negative 6 plus 2. Y is a negative 4. That's just following the steps until I come up with it. So my solution should be an x comma a y. Here's my x. Here's my y. So my solution for this set should be negative 2 comma negative 4. Now, if you want to check that with your calculator, what I can do is enter the 2 original equations that I had. I had 3x plus 2 and negative x minus 6. I can graph it. Now I can graph it, and I can see my solution for these 2 on here. It's going to be a negative negative. It looks like it went over negative 2 and down negative 4, but I don't have to trust that. I can do my second trace, 5, enter, enter, enter. And I see right here that my solution says x is negative 2, y is negative 4. So that's the solution that I got when I worked it out. So that's one of the ways we can check it. However, if you look, most of these equations are not solved for a variable, and particularly not solved for y. So what we're going to do is pick a variable. I always pick, if I have one, a single positive variable. So in this one, x is a single positive variable. I'm going to solve for x. And then I'll replace this x with whatever x equals. So to solve for x, I subtract 2 y's from each side. And now I have the new equation. I'm going to write it down here. X equals negative 2y plus 2. I'm going to substitute this value in for this x. So I'm going to write 5 times, instead of x, I'm going to write negative 2y plus 2. Do not forget this other minus 3y equals negative 29. I have to distribute this 5 to each term, not just one but both. Negative 10y's plus 10 minus 3y's equals negative 29. Now I have 2 terms that are on the same side. I can get rid of the 10 right now, and I'm also going to add the negative 10 and the negative 3. So that was a 0 pair. This adds up to a negative 39. The 10y and the negative 3y adds up to a negative 13y. Now all I have to do is divide by negative 13, and I'll have my answer. Y equals 3. Now I can take this 3 and substitute it back in for a y in either equation. I'm going to use the easiest equation, x plus 2y equals 2. And I'm going to say x plus 2 times 3 equals 2. 2 times 3 is 6, so x plus 6 equals 2. Subtract 6 from each side, and I get that x equals negative 4. So my solution for this is negative 4 comma 3. Notice on the original equation, we found the value of x first, and then we solved for y. In this one, I found the value of y, and then I solved for x. It doesn't matter which one I do as long as I do the correct steps. So those steps once again. Select an equation and solve for a variable. Substitute that variable in the other equation with the value of that variable. The result is an equation with only one variable. It'll be all x's or all y's. There'll be more than one, but all of them will be x's or all of them will be y's. So I solve this equation for that variable that's left. When the value of that variable is found, we'll substitute it back into one of the equations and find the other variable. So let's try a few of your practice homeworks. I asked you to do up through the odd numbers. So let's start with number 5 right here in the middle. I don't have a single positive variable, so I'm going to go the easiest route. I'm going to solve for a single negative variable. So I'm going to do that differently than we normally do it. I'm going to add a y to this side. I'm also going to subtract a 5 from this side. What that'll do is get the 5 away from that side, and it'll move the y to that side. So I end up with 2x minus 5 equals a y. Should make that more obvious that those are y's. So I added a y each time, so now I have a positive y. Now I need to substitute the value of this y, which is 2x minus 5, into this equation. So it'll look like this. 3x minus 2 and our value of y, which is 2x minus 5. It goes right into these parentheses. And that's going to equal 4. 3x, I'm going to distribute this negative 2 to each term. Minus 4x plus 10 equals 4. 3x minus a 4x is a negative x. I'm also going to subtract 10 from each side at the same point. So I get x, a negative x equals a negative 6, which means that a positive x would be 6. Now I'm going to substitute this x back into one of my equations, and I'm going to use the easiest one. 2 times 6 minus y equals 5. So now this x becomes, this 6 becomes that x. 12 minus y equals 5. I'll subtract 12. I get that a negative y equals negative 7, or y equals 7. So my solution for this should be my original x of 6 and my y of 7. In case you're wondering if that works out, we can put those back into the equation and solve it. So I'm going to do that on a separate sheet of paper, possibly. Some pink paper, and I'm going to put my 6, 7 into both equations just so you see it works for both. So it'll be 2 times 6 minus 7 equals 5. That's just substituting the x and the y into this equation. 12 minus 7 equals 5. 5 equals 5. Perfect. Now let's try it in this one. 3 times 6 minus 2 times 7 should equal 4. 12 minus, I'm sorry, 3 times 6 is 18, minus 14 equals 4. 18 minus 14 is 4. Sorry, you can't see that. So 4 equals 4. So this works for both equations. Notice I'm not getting a 6 or a 7. I'm just getting a value that's equal, which is all I need. Putting the 6 in for x and the 7 in for y, the value equals 4. That's what I'm looking for. All right, let's try a different one. Some of these on the bottom tend to be a problem. So I assume y'all would want me to do this one, but I'm actually going to, well, I was looking for one that I didn't have a single positive value for x or y. So why don't I do one like this? And on second thought, I'll do this one because it looks like it's going to be a little harder for you. So I need to pick a variable to solve for. Oh, y'all don't have to do number 8. So let me pick, let's do number 9. I'm going to pick a value to solve for. I can either solve for x or I can solve for y. I always do use the path of least resistance. So I'm going to solve for x. That means I add 2 y's to each side. So I have x equals 2y plus 0.9. I'm going to replace this x into this equation. So it'll look like this. 4 times the x is 2y plus 0.9 minus a 3y. Do not forget that 3y that's there. I distribute the 4 to both terms, and I get 8y plus 3.6 minus 3y equals 13.1. I'm going to do 2 steps at once here. I'm going to combine my like terms, the 8 and the negative 3, and I'm going to get rid of the number because I don't need it on the same side as a y. So I get that 8 minus a 3 is going to be a 5y, and 13.1 minus 3.6 equals 9.5. Divide by both sides by 5, and I get that y is equal to, 5 will go into 9 one time, I'm sorry, 5 into 95 is 19, and there's a decimal place, so it's 1.9 times. Now I have to replace this y with one of the values up here. I'm going to do the one that's easiest. For me, it looks like x minus 2y equals 0.9 will be easiest. So I'll do x minus 2 times 1.9, my value of y, should equal 0.9. So x minus 2 times 1.9 is 3.8 equals 0.9. I'm going to add 3.8 to each side, and I get that x equals 4.7. So my point should come out being 4.7 comma 1.9. It's a lot of work with a lot of numbers. Don't lose track of your decimals. Use a calculator if you must. Don't let the fact that you're doing math in your head make you get one of these questions wrong. I've done 2 of them. That leaves you 1, 2, 3 problems to do on your own. They shouldn't be difficult because I left you the easy ones. The hardest one you're going to have is this one. But there's something you should already notice about it, and you should already be thinking about. If you have any trouble, let me know before class tomorrow.